Hey kiddos, today we're going to talk about how to name bicyclic alkanes. Bicyclic alkanes, bicyclic means that there are two rings. Cyclic means that there's a ring, right, that goes back around on itself. And so bicyclic means that we've got two rings fused together. And of course, if you know much about your upper biology, you'll know that of course we can have structures where we've got even more than two rings fused together. But at the level that we're at, we're going to stop with naming bicyclics, and that will give you enough idea to be able to go on from there and to be able to figure out what you need to do from there. And two rings fused together means that you have two ring structures and they're not separated by like another carbon or something, but rather that they have two carbons in common. Those two carbons we're going to see are called bridgeheads because they're what essentially forms a bridge between the two rings that are going on there. So how do we name these? So we're going to jump in, and the first thing that we're going to do is find the parent chain, okay? That's what we've been doing all along for alkanes, and so we're going to do that first. What's going to be a little bit different for us, of course, is that in the bicyclic structure, the parent is the two rings. And so what you want to do in that case then is count up the number of carbons that are in your two rings, and that will sort of give you what your base name is going to be. So we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons in this ring. And so I know that the base of my name then is going to be octane. And so I'm going to go ahead and come down here. We're going to start writing the name for this compound, but I'm going to start with that base. So that's my parent. So octane is what it is. Okay? So now the next step then is to look at the rings. So the second step here for our bicyclic compounds is to find the three paths. And so what I mean by three paths are you're going to have paths around the rings from the bridgeheads, okay? So remember we said before that we identified the bridgeheads, and I probably should have circled those for you. So let's do that now real quick. Let me circle those two carbons there, and then let's note that those are bridgeheads. Okay? So those two carbons are the bridgeheads. So we need to find three paths between the bridgeheads. So these two bridgehead carbons are like the most important thing in our bicyclic naming. So we need to find three paths between them. And there's always going to be three paths. And we're going to differentiate them and call them the longest path, the middle path, and the shortest path. What do we mean by paths? Well, so we're going to get from this bridgehead to the other bridgehead. So we could go this way, we could go this way, or we could go around this way. So obviously going around the hexagon here is going to be the longest path. And so what you need to do when you're figuring out longest, middle, and shortest path is the really important thing is how many carbons are in between the bridgeheads on that path. So if we go around this longest path, okay, around the hexagon, we're going 1, 2, 3, 4 carbons are in the ring between that hexagon. So I'm going to come over here then, and I'm going to say on my longest path, there are 4 carbons. Okay? My middle path is this one over here, is on the square part here. And so we've got, if we go from one bridgehead to another, it's 1, 2 carbons in between them. You don't count the bridgehead carbons, you count the carbons that are in between them. And so in this case, I've got 2 carbons in between. And then on my shortest path, okay, between the bridgeheads, I actually have no carbons in between them. And that is relatively common. It's not all the time, but it's relatively common to end up with no carbons in between those two. And so that will give me a 0. Now, why that is going to be so important for naming is because what we're going to do for the name then is we're going to come down here and we're going to amend our base name. And we're going to put a structure in that looks like this. We're going to put in brackets, and then we're going to take those 3 numbers, longest, middle, and shortest, and we're going to write those numbers in there, okay? And that is what goes right before your parent name. So in this case, we're going to have 4.2.0 octane. And since this is a bicyclic compound, we're going to go ahead and in front of that, we're going to put the word bicyclo in front of that. So we're not done naming it. If we didn't have any branches on this, we actually would be done naming it. If it was just the 2 rings, that would be the name of this particular compound. Now, since we do have branches, and since most of the time you're going to have branches, that means that we're going to have to come back and do some additional work to add on then our prefixes, and that, of course, is our next step. But the numbering part here is important because it goes in a very sequential, orderly fashion, just like everything IUPAC does, which is the numbers are longest, middle, and shortest. You could think about it if you wanted to give yourself an acronym, it would be LMS, longest, middle, shortest. And remember that the number there is the number of carbons in between the bridgeheads on that path, not counting the bridgeheads. Okay, so let's do the next rule. Okay, so rule 2 was really the only place that we deviated from our normal alkane naming nomenclature stuff, because we had to deal with how do we number this and get that little bracket part for the paths there. Remember, longest, middle, shortest path, number of carbons in between them. So now, what do we do for the substituents? So we have substituents, and in fact, we know what we have. We've got 1, 2, 3, 4 methyl groups. And so in your head, you already sort of know that this is going to be a tetramethyl. And in fact, we could go ahead and write that, but we'll hold off on it for just a second. But the question is, how do I assign the numbers then? Like, where do I start? I've got so many different places. I mean, I know normally I would start at the end closest to where there was a substituent, but I've got this ring structure, so I don't really have an end in any case. And then, so like, do I start here where I'd make that one, or like, how does that work? Well, the pattern for bicyclic structures is that you're going to assign the locants, and you have to go in LMS order. In other words, you have to go in the order of the paths, longest, middle, shortest path, to be able to assign the numberings. Now, that still leaves you a couple of decisions, okay? So there are 2 ways that I could number this, and I'm gonna go ahead and number them and do them in different colors so that you can see both of the ways, and I'm going to leave them both up there, so don't get confused. Make sure that you know that there are 2 different numbering conventions here. So you have to start at the bridgehead, and then you have to number along the longest path, the middle path, and then the shortest path. Now in this case, since I had 0 carbons in my shortest path, there won't be anything to number there, but that's still the convention that you would follow. So carbon 1, 2, 3, 4, 5, 6, 7, 8. And if we did that, then what that would give us, and I'm going to write that off to the side here. So what that would give us in that case is I would have a 2, 5, 5, 8 tetramethyl bicyclo-4,2-octane. So let me write that out real quick. That is not, of course, the correct answer, and you'll see why here in just a second. 5, 5, 8 tetramethyl. And you should, of course, be able to see why that's tetramethyl. There's 4 methyl groups, carbon 2, 2 at carbon 5, and then 1 at carbon 8, tetramethyl. Okay, and yes, to answer the question that students often ask, do I have to put the 5, 5? Couldn't I just put 5 once? No, because the fact that you put 2 5s lets you know that there are 2 methyl groups there, not just 1. If you put 2, 5, 8 tetramethyl, someone would be like, why wouldn't that be trimethyl? That doesn't make any sense. So you should have as many numbers as your prefix indicates there. Okay, so that's why that's there. That is not, of course, the only way that I could number that. So I'm going to number the second one here in yellow, just so you can sort of see a little bit of a difference. So I'm going to number the other, going the other direction, meaning I'm going to start at the other bridgehead and go around. So 1, 2, 3, 4, 5, 6, 7, 8. And what that is going to give us is still tetramethyl, but what that's going to give me is 2, 2, 5, 7 tetramethyl. Now, why would that be a better one? And most of you already know the answer to that, and that's because, of course, those numbers are going to be lower than they were in the other case. And remember that when you're naming alkanes and you're numbering substituents and putting the substituents where you were, that you're trying to get to the lowest number scenario there. And so this is a much lower number. Now, one thing that's tricky in bicyclics is that you have to go longest, middle, and shortest path. That is the overwhelming concern before the normal numbering pattern of, hey, I'm just going to go this way and then go around or whatever. You have to go along the longest path. Now that still leaves you 2 options every time because you've got 2 bridgeheads. And so you could go along the longest path that way, or I could go along it that way. So that gives you a couple of possibilities. If those possibilities are sort of otherwise equivalent, then you go back and say, hey, which one of these would be preferable? And then what if they sort of both totaled up to the same number? And remember that in that case, if you were doing your numbering, that what matters is you want to start nearest a substituent. Okay, so if you had to choose between a 1 and a 2 to start with, then you would definitely want to choose the 1 over the 2. In this case, we both started at 2, but having 2 at 2 makes more sense than having 2 at 5. Okay? So let's work one more just as an example. We'll run through it a little bit more quickly just so that we're not sort of bogging down time on the video, but I want you to see one more that maybe looks a little bit different than this one. All right, so let's work our second example. This one looks a lot different and looks more complicated. Like usually when the students first see a bicyclic that looks like this, they sort of start to panic a little bit because they're like, I don't even know, like how are there 2 rings here and like what does this mean that there's a break here? Well, remember we're doing a 2-dimensional representation of a structure. This is this line going straight across to here. We show a discontinuity or a break in it because it's behind this line. And if we connected it to that line, then that would indicate there's another carbon there, right? Which is not how this works at all. And so where is there a ring? Well, there is a ring going here, okay? Okay, that's a ring on this side. And then there is another ring that is following along this path here. And so this is still a bicyclic compound. I've got 2 rings that are fused together. And in this case, you can really see the bridgehead part of this because that means that like there's 2 carbons to sort of anchor the chains together. Okay, right there. Those are bridgeheads. And then there's like a bridge between the 2 rings. That's the bridgehead part of it. So we're going to name this the same way we did in the last case, which is we're going to start out and see how many carbons do we have on the 2 rings. We're not going to worry. I've got a substituent here, a methyl, and an ethyl there, but we're not going to worry about those yet. I'm going to count the rings and see how many carbons we have there. So I'm going to start at the bridgehead. 1, 2, 3, 4, 5, 6, 7, 8. You got to count that top carbon there. That's part of the bicyclic structure of that ring. And so again, we have an octane for our root name. So we'll start there. Okay, so that's great. So now we're going to worry about where are our paths. Well, this side looks a lot bigger, so let's check and see if that's sort of our longest path. So we've got a path 1, 2, 3 carbons, okay? And then what would the other path be between the bridgeheads? So it's 1, 2. Remember that there's no carbon in between there. That's just a discontinuity because of that upper part poking out there, okay? So that would be 2, and I'll come back to that in just a second. And then there's our third path right there. So real quick, I'm just going to make myself a little note. What's my LMS? So we're starting here. 1, 2, 3. Okay. 1, 2. That's it. And then there's 1 carbon in between them on the shortest path. So now I can come down here and name the paths. Remember, it is bicyclo. I can't tell you how many students do everything else right and forget the bicyclist, so don't forget that part. And now we're down to our substituents. So real quick, I'm just going to like sort of briefly say, okay, this is an ethyl. Okay. Don't ask me why I curved the Y and not the L and not the Y. Okay, methyl. So I know that I've got a methyl and an ethyl, and now I have to put my locants on, right? Now I have to number things. And so remember that you have to number according to the longest path first, and then the middle path, and then the shortest path as far as our numbering. So I kind of already know that since this is an octane, and I'm numbering shortest path, that I'm going to end up at 8 there regardless. You didn't have to write that first. That was just, I knew that automatically, and so that sort of helped me out. So the question is, do I start here, or do I start here and number along the longest path? Well, obviously, I already sort of know where it goes, but if I start here, then my first substituent is at the second carbon. But if I start with this one, my first substituent is on the first carbon. So I already know that that is preferentially where I want to start, is with my substituent on carbon 1. And you might be thinking to yourself, hey, I thought you told us in alkanes that I couldn't have a 1-methyl something. That's true if it's like a chain of alkanes, but in a ring structure, that's not true because this methyl is not part of the ring, and so therefore it doesn't make the chain itself any longer. And so I'm going to number this as carbon 1, 2, 3, 4, 5. That was the longest path, right? 6, 7, and then 8 would come up on that tallest path. And so what that then is going to give us, and remember that you name your substituents alphabetically, right? So ethyl comes before methyl. So I've got a 4-ethyl, 1-methyl. 4-ethyl, 1-methyl, bicyclo-3,2,1 octane. Those names look really complicated, but here's the beauty of all of this, and I hope that as we're working through the nomenclature and stuff, that this is really clicking with you guys, because it's a very systematic method. You're not having to guess things. And one of the things that I've always loved about teaching this nomenclature stuff to students is that once in a while they'll point out that I made an error, because it is a nice sequential order of things. There's a sequential order to the way you do it, and there are specific rules that you have to do to follow it. And so that usually pans out pretty well most of the time for students. Obviously, you'll need to practice a lot of these to get them right, particularly in the numbering. That locants on the bicyclics is what tends to throw students off. But I think once you practice and do 10 or so, you'll have a pretty good handle on it, and hopefully that will really get you where you need to go for naming bicyclic alkanes. All right, thanks, kiddos.